Hey, hi, hello everyone. Good evening. How are you all? You all are doing well with your best of health, right? Okay, let me know, guys. I'm an audible to everyone. And one more point, whether my screen is visible to everyone. देखो एक बार बता दो in the chat box में if there anything problem is there. It will make sure to cross check here. सब कुछ ठीक है क्या? Then it's बढ़िया. Then it's great. Okay, guys, we're going to start our session now itself. No problem. Hi, guys. Jane with Davangere. Good evening. Am I audible, right? Let me know through the chat box quickly. Yes. How are you all? After a long time, I'm excellent. Okay, today in the we are in the last part of our wave optics, guys. Okay, wave optics ka last topic we are going to study today. Yeah, I'm fine. Good. How was your preparations towards the exam? Actually, pre-board also postponed now. You have a good time to prepare your examination now, right? Put your maximum effort as possible as. Yes. Okay. Okay. All the best. Let's start. Okay. In this, the topic is the polarization of light. Okay. Polarization को analyze करना है इधर. Polarization of light क्या होता है? Simply first I will give an introduction. Okay. Consider this a light object, right? This is a source. Right now, source means it will emit the light in all the direction. It's an actually basically light source. Correct now, light source means in this light source, it is a containing of electric field and as well as the magnetic field. Correct. Combinedly, we will call this one as an electromagnetic waves. Electromagnetic waves means here the light source which is emitting the wave, that it is consisting of electric field also along with the magnetic field also. Both the waves are associated with this light source. Correct now? Yes. Here in this light source, electric fields are like this. Okay, just imagine this is a y-axis. Magnetic fields are in z-axis. Okay, they combinedly moving perpendicular to each other. देखो ये दोनों को बीच में एंगल कितना होता है? 90 डिग्री होता है, राइट? ये दोनों वेरी हो रहा है y axis and z axis में, but their propagation direction will be along x axis here. Correct now? Okay, here these waves like this, these are considered first wave. If I consider from this source, there are plenty number of waves will be emerging from this source like this. N number of waves are coming. Okay, they are having a electric field and magnetic field in different direction. Okay, we call that one as a, that's why we call this wave which is emitting from the light source as an unpolarized light. What we will call this one as unpolarized light. Unpolarized light or unpolarized wave. इसको हम polarization करना है. Polarization means देखो इधर off of the figure you can observe here only the electric field. That's it. There is no magnetic fields here. Correct? Magnetic fields actually they are varying in z-axis no simultaneously. These magnetic fields are not here. Correct? Here only electric field is present. Correct? Now you have an idea about it. What happened in between these two parts? Correct? Now, either electric magnetic field, either only electric field are there. The simple difference is that here both combination of electric and magnetic field are random in direction. No, that's why we call this one as an unpolarized light. Here only the electric field is coming out after some process. I will tell you what is the process. Correct now. Only electric fields are present here. Dekho. Like this distillation here. Not a, it is not a chemistry distillation. This we are going to distill the electric field from magnetic field. Okay, only we are taking only one field, right? This is now become polarized light. Polarized light. Okay, this phenomena making unpolarized light to polarization of light we call polarization. Clear enough? This is a topic. This is an actual topic which I want to talk in this class. Okay, before taking this topic, let us take a quick recap what we discussed in the previous class. Previous class में क्या-क्या discuss किया था हम? Diffraction of light discuss किया था. Sorry, this diffraction of light is over. Later on, we discussed about the Fresnel diffraction. Fresnel diffraction क्या होता है? Actually, same diffraction होता है, but here Fresnel diffraction. This is a screen, no, right? This screen is kept very closer to the this aperture, means slit के very close means पास में रखता है. Okay, to analyze this one. At the time here, it is making an angle. Is there? No, this angle will give the dimension of this bright fringe. Okay, based on that one, we find out one equation. There's a Fresnel distance equation, that is ZF is equal to A square upon lambda. Okay, this is a simple equation. Keep remind this one. Okay, later on we talk about the resolving power. Resolving power क्या होता है? Actually, when two closely lying particles are closely lying, means we need to make, we can't able to make separate that much of tiny particles, but we want to visualize that one as a separate, means we need some instrument. By using that instrument, we can easily view those two closely lying particle as an separate. Correct now? This is known as the resolving power. Correct ना? Later on, the resolution होता है ना, two instruments से होता है. First one is from the microscope, second one from the telescope. Right? Microscope से visualize कर दिया हम, and we find out the value of the resolution power of the microscope. That is, hey, 1 second, ये थोड़ा mistake है ना? देखो इधर, resolution power is inversely proportional to the distance. How much distance it is there from the particle. Yes, here थोड़ा सा mistake हो गया. This is distance. It is inversely proportional. Okay, distance value हमको आ गया था lambda upon 2 mu sin theta. Okay, इसको उल्टा रख दो. Okay, resolution power होता है, देखो इधर थोड़ा सा mistake हो गया. Okay, sorry for that. Resolution power will be equal to 2 mu lambda, so 2 mu sin theta upon lambda. Okay, no. Okay, correct it. Okay, next thing is that Doppler effect. Correct now? Doppler effect क्या होता है? Actually, you know the Doppler effect in sound. Correct now? Yeah, just imagine that you are standing in the bus stand, means the vehicle which is coming from a long distance. Actually, vehicle के पास sound है. That is, you can hear the sound of the vehicle very less amount when it is far distance. As it is approaching towards you, means the intensity of sound keep on increases. Correct now? At the exact point of view when the vehicle will come, no, that point में vehicle sound बहुत ज़्यादा होगा, maximum होगा. And as further the vehicle which is moving away from you, no, again the continuously intensity will be keep on decreases. Right? When it is coming approaching towards you, means intensity is increasing, sound intensity. At exactly particular your point, intensity is maximum, sound wala. I'm talking about sound. Oh shit. Okay, now I'm an audible, right? I'm audible. Okay. Sound is increasing as the vehicle which is approaching towards you. When it is approaches exactly your point means intensity of sound is maximum, and further it is moving away from you means again the intensity of sound is decreases. This phenomena is called the Doppler effect in sound. Okay, in a similar way we need to know about the Doppler effect in terms of light. Light में क्या होता है? Yesterday I told you light means, देखो इधर, this is a source of light, white light, correct ना? You are present here means, here I explained that one. Okay, here present here, light of source which is actually emitting the white light, correct now? Just imagine that the source which is moving away from you, this is you, this is a person P. Okay, if it is moving away from you means the wavelength will be keep on increases. Wavelength क्या होता है? Increase होता है. That's why at that moment for your eye it will be looking like the color which is emitting by the source, which is looking like a red color when it is moving away from you. I explained yesterday. Correct now? When it is moving towards you, the wavelength keep on decreases. Correct now? That time actually source emitting the white light only, but it is looking like a blue in color. Correct now? This process we call Doppler effect in light. Correct now? If it is source moving away means you can clearly look that source as a red in color. That's why we call this one as a red shift. When it is approaching towards you, the white source which is looking like a blue color, it is blue shift. Okay, don't ask like that, sir. Now car is approaching towards me. Car head bulb pe white color. Okay, when it is approaching towards me, why we can't able to see the blue color then? When it is moving away means why we can't able to see that red color? It change hota hai, minute amount. Okay, that's why we can't able to see. Yesterday I solved one problem, enough, but by using that problem we can clearly identify there. No, a star with wavelength it is emitting around 6,000 angstrom. Okay, when it is moving away from you means the change in wavelength value कितना आया था? Only 1 angstrom आया था. 6,000 angstrom किधर? 1 angstrom किधर? Correct ना? Change in value थोड़ा कम होता है. Okay, कोई problem नहीं. This is all about what we discussed in yesterday class. Okay, guys, if you have any doubt means please do drop your doubts in the chat box. Otherwise, we are going to continue the class. I'm waiting for your answers. Hope you don't have any doubt. Okay, then it is cool. इधर एक क्वेश्चन है. क्वेश्चन क्या है? हाँ, a slit or an aperture, diffracts the light. Obviously we know that. देखो इधर, this is a slit. Okay, when a plane wave will be incident on this one means A, B. Okay, this much portion only it will be enters here. Correct now? When it is enters, actually diffraction hota hai. Like this, it will be diffracted up to this much portion. Condition क्या बोला था मैंने? This slit width ये है ना, the value of ये slit width, it should be less than or equal to the wavelength of the lambda. When it is in this condition, no, then only we can able to analyze the diffraction pattern, or else it is highly difficult. We can't able to separate the bright bands and bright and as well as dark bands. Okay, we need to separate those means the condition should be satisfied. Correct now? Okay, let us go through the question. Even then, we say light is travel in a straight line. The ray optics is valid. Comment they given. Okay, they are asking for the comment. What you will say for this one? Means we know that light will be travel in a straight line. Okay, straight line हो रहा है. But इधर diverge भी हो रहा है ना. Even it is diverging also. In ray optics, what we are saying, it is a straight line. How can we able to predict this one as straight line? This is what the question. Answer तो simple है. Answer तो very simple है. क्योंकि इधर डिफ्रैक्शन हो रहा है. डिफ्रैक्शन पैटर्न को हम satisfy करते हैं with the help of Fresnel diffraction. Fresnel diffraction. ओके, फ्रेस्नेल डिफ्रैक्शन के साथ क्या होता है इधर, we are saying light is a light travels in a straight line, no, by using means our eye have an aperture, क्या बोलते हैं उसको, iris, okay, which is light entering through our eye, उसका अपर्चर होता है आई का अपर्चर, ओके, इट विल बी अराउंड 3 मिलीमीटर, इतना स्मॉल होता है. जस्ट टेक एन एग्जांपल, लाइट विच इज कमिंग फ्रॉम द सोर्स, ओके, उसका वेवलेंथ है, टेक एन एग्जांपल 5000 एंगस्ट्रॉम, 5000 angstrom. The distance with how much it will be covered by using Fresnel diffraction, you can see that is ZF will be equal to a square by lambda होता है. Okay, just you put the values here. A square means a value, aperture value 3 into 10 to the power of minus 3 millimeter, correct now, full square, milli means 10 to the power of minus, divided by lambda कितना था 5000 angstrom means 10 to the power of minus 10. After solving this one, you will get Fresnel distance will be 18 meter मिलता है तुमको. Okay, I already solved this one, just by that's why I'm writing this one. Okay, 18 meter means it's very near one, 18 meter. And moreover क्या है ना, इधर diffraction हो रहा है, ये 18 meter it means it's a short distance, correct? In this short distance, whatever the light will be diverged, no, we can consider this one as a straight beam of light, like this. Like this we can consider. Okay, that's why it is valid in the ray optics. Clear? Short distance है ना, इसलिए. ओके, चलो और एक क्वेश्चन है मेरे पास. क्वेश्चन क्या है, a spectral line for a given element, for a spectral line given element of light, एक element है source of light, okay, वो क्या कर रहा है, wavelength means light को emergent कर रहा है, okay, light received from a distance of star is shifted towards the longer wavelength side by 0.025%, okay, calculate the velocity of a star in line of sight. ओके, इधर क्या कैलकुलेट करना है, वेलोसिटी कैलकुलेट करना है, स्टार कितने स्पीड में मूव हो रहा है. ओके, कैसे कैलकुलेट करना है, I didn't told about the formula now. Actually, yesterday class we discussed the formula for change in means percentage of change in wavelength. Okay, RS we can take that one as fractional change in wavelength or fractional change in frequency. It is equal to like this. Fractional change in wavelength is equal to V radial upon CV written. Okay, this is a formula to find out the change in wavelength with respect to the velocity of star, and C means light speed of light. In terms of frequency, we can calculate this one. Delta nu upon nu is a fractional change in frequency is equal to V radial means relative velocity of a star or any object which is emitting the light divided by speed of light. Okay, here what they given actually, what we need to calculate actually, velocity of we need to calculate this one. Okay, change in percentage, wavelength का percentage दे दिया, कितना परसेंट चेंज हो रहा है. ओके, द वैल्यू इट इज गिवन, सी वैल्यू आपको पता है. ओके, पुट दिस वैल्यूज एंड फाइंड आउट द वैल्यू ऑफ वी, फाइंड आउट द वैल्यू ऑफ वी. I will give you exactly 2 minutes. Okay, I need value of V. Find it and send the answer. Did you got the answer, guys? सिंपल है, देखो इधर चेंज इन वैल्यू दे गिवन कितना 0.025% मींस 0.025% में दिया है. ओके, इफ यू वांट टू कन्वर्ट दिस वन इनटू न्यूमेरिकल मींस इट्स वेरी सिंपल. क्या करना है, डिवाइडेड बाय 100 करना है. करेक्ट है ना? राइट? डिड यू गॉट द आंसर? नो, चेक करो एक बार. चेक करो, चेक करो. ओके कूल. हाँ, देखो देखो एक कितना आता है, देखो इधर. If you shift the digit means here it will become 10 to the power of minus 1, 10 to the power of minus 2. Okay, 2.5 into 10 to the power of minus 2 होता है ना. 100 means it is nothing but 10 to the power of plus 2. If it is comes to numerator means again 10 to the power of minus 2 होता है. Okay, then this value will become 2.5 into 10 to the power of minus 4. This is nothing but delta lambda upon lambda value मिल गया. Correct ना? Then substitute the values here. Delta lambda remaining thing here, 2.5 into 10 to the power of minus 4. V radial we need to calculate. C को इधर multiply करो. C means it will be 3 into 10 to the power of 8 meter per second is equal to minus V radial. Correct ना? Then 2.5 into 3 means it is nothing but 7.5 into minus 4 plus 8. It is nothing but 10 to the power of plus 4. Correct now? Velocity will be in meter per second. Correct now? Then the value minus V radial hai. Okay, or else we can write V radial is equal to minus 7.5 into 10 to the power of plus 4 meter per second. Here, this negative sign which indicates that the star or the source which is emitting the light which is moving away from us, right? I mean, means the sign which indicates. Okay, cool. So polarization start करता है. Okay, देखो इधर. Here I already told you a source means इस source के साथ इलेक्ट्रिक फील्ड भी होता है, मैग्नेटिक फील्ड भी होता है. These are simultaneously varying electric and as well as magnetic field. देखो इधर, here the electric field and as well as magnetic field actually mutually perpendicular to each other. Correct है ना? ये blue color देखो and this is the red color one. Red color is a thing like that electric field. Blue color वाला magnetic field. Simultaneously they are varying x and y and as well as ये कौन सी axis है? Z axis, and their propagation is moving along the x axis direction. Right? देखो, this is the electric field, this is the magnetic field. Correct now? They are mutually perpendicular to each other, but their propagation direction will be in x axis. Like this, if you consider this is a source means, okay, from this source plenty number of electric and as well as magnetic field will be emitted. Okay, this all the waves, light waves having electric fields, magnetic field. That's why these are in random. Correct ना? Random portion में होता है. That's why we call these waves as an unpolarized light waves. Unpolarized light wave. Okay, now the target is that we need to change this unpolarized light to polarized light. Polarized light again ಮಾಡಬೇಕು, change ಮಾಡಬೇಕು. Okay, how to change this one? To change this one, we need to make one experiment. Okay, experiment कैसे करता है? I will explain you through the simulation. Okay, let me know my screen is visible to everyone or not when I'm saying. Okay, when I'm going to ask, no, that time tell me. That screen. Guys, let me know, is my screen is visible to everyone? This is a web page screen. Is it visible? And answer. Yes. If it is possible, means just zoom your screen up to this setup. Okay, setup कितना है ना, उतना zoom करो. देखो इधर, in this portion, green color and blue color, red color है ना, this is electromagnetic waves. Correct? Actually, these rays are coming from the source of light. इधर क्या कर दिया? Only electric fields are coming, no? Here in a second portion, mid portion में, right? What I'm saying? And last portion में again electric fields are coming. Here two means experimental operators are there. Just a minute, I will show you. देखो इधर क्या है, correct ना? Actually here electromagnetic waves which are emitting from the source in all the direction. But इधर slits के जैसे है ना, इसको हम कहते हैं polarizer. क्या कहते हैं इसको? We are going to call this one as an polarizer. देखो इधर, right? Actually what they are doing here, simultaneously x y z axis में, sorry, electric magnetic fields are vibrating, correct ना? Electric field actually they are means varying only in x y axis, correct ना? In that axis इधर क्या है? Slits are there, openings are there. Okay, those lines are only traveling inside, correct? Look at here, remaining are all black. Or else we can say from this polarizer, is a polarizer, no, this polarizer observes remaining waves, light waves, and they allow only the light waves which are parallel to the slits, correct? Then after देखो इधर क्या हो रहा है? Only the electric signals are, or one plain polarized lights are coming. Hey, plain polarized lights are coming, no? These are the plain one, plain polarized light. Okay, next thing देखो इधर, इधर और एक है, इधर plain polarization are coming from the first thing, that is a polarizer. इधर और एक same device है, we are going to call this second one as an analyzer. Analyzer, both are same. Analyzer क्या करता है? Whether the coming light is polarized or not, it will be detected from this device. Okay, the device which is detected the wave which is coming from the polarizer, which is polarized or not, is called the analyzer. Either second one है analyzer, first one है polarizer. Okay, देखो क्या होता है. Now what I will do now, first polarizer को I will change the angle. If I change the angle means, देखो क्या हो रहा है उधर, देखो angle change किया मैंने, right now again it is accepting plane waves which is coming to the parallel for the polarizer. Plane wave को pass करता है, correct ना? But इधर क्या हो रहा है देखो एक बार, if I am going to change the angle further means polarizer का angle change कर रहा हूँ. Top view देखो, top view, shut just a minute. हाँ, now it is visible. देखो polarizer का angle change कर दिया मैंने, change कर दिया. When it is perpendicular to the analyzer, हाँ देखो polarizer क्या कर रहा है? उसका प्लेन में आता ना वेव, उसको पास कर रहा है, मीन्स इधर कमिंग इन मिडल है ना, मिडल में वेव्स आर कमिंग, नो दोस आर दी पोलराइज्ड वेव्स, करेक्ट। बट हियर एनालाइजर में क्या हो रहा है एक्चुअली, those waves actually coming plane, no, for them it is perpendicular, right? That's why again this is acting as a polarizer and it blocks all the light, and finally what we will get, zero intensity वाला। एम्पलीट्यूड तो नहीं है ना इधर, देखो सिंगल लाइन आ रहा है, मीन्स इंटेंसिटी क्या हो गया, डिक्रीज हो गया। ओके, ये छोड़ दो, कोई प्रॉब्लम नहीं। यस, जस्ट अ मिनट। हाँ, ये भी नो। देन एनालाइजर है ना, एनालाइजर को चेंज करते हैं। दिस इज इन मिडल पोर्शन है ना, दिस इज द वेव्स आर ऑल पोलराइज्ड वेव्स। ओके, नाउ आई एम गोइंग टू चेंज द एनालाइजर एंगल। नाउ इट इज पैरेलल टू द प्लेन वेव्स। इफ आई चेंज द एंगल लाइक दिस, मीन्स देखो इंटेंसिटी मीन्स एम्पलीट्यूड क्या हो रहा है, डिक्रीज हो रहा है। ऑब्जर्व करो एक बार, एम्पलीट्यूड डिक्रीजेस मीन्स इंटेंसिटी आल्सो डिक्रीजिंग। लास्ट क्लास मैंने बोल दिया था, करेक्ट ना, it is in intensity decreased by 4 times, right? Further I decrease the angle, further I decrease the angle, amplitude become lesser, 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 lesser. Finally if it is perpendicular to the plane, means complete intensity will be stopped. Okay, this is the phenomena we call the polarization of light, the experimental demonstration. Is it understood, guys? Let me know through the chat box quickly. Quickly. Is it understood? Guys, I need your responses. Please do response. Please do give a response. Okay, this is all about the experimental evidence. How to understand this one, I will explain. देखो इधर, experimental evidence means source of light है, source of light में दो तरह का wave होता है ना। Okay, this is a source of light means इसके पास waves आता है ना, इधर दो type wave है। First one is electric wave which is varying simultaneously r along the x positive y and negative y axis continuously like this, correct na? And one more wave is there, that wave actually acting perpendicular to this one. Consider this an electric wave, perpendicular means inside the board like this, correct? We call this one as an magnetic wave. Okay, now just imagine these are the propagation, like this they're going to oscillate and they will be propagate along the x-axis, correct now? Okay, cool. Now how to represent this one, it is very important. How we are going to represent this one now, it is very important. देखो इधर, imagine this is the first wave which is varying simultaneously y-axis. Okay, ये perpendicular है ना, इसको कैसे indicate करना है, वो एक तरीका है, right? If you make on dot, no, it will indicate that here another wave is there which is actually acting inside the plane, inside here my computer laptop board, correct na? Like that you need to think. This is the first wave, this is the second wave, दोनों है, means it is an unpolarized light. What we are going to call this one as unpolarized light. अनपोलराइज्ड लाइट हो गया। नाउ इसको पोलराइज करने के लिए हमारे पास क्या होना चाहिए, एक डिवाइस होना चाहिए, वी कॉल दैट डिवाइस एज एन पोलराइजर। जस्ट इमेजिन दिस इज द पोलराइजर, राउंड शेप वाला है ना, लिख दिया ना मैंने इधर, दिस इज द पोलराइजर। पोलराइजर में क्या होता है एक्चुअली, द पोलराइजर कंटेनिंग द स्लिट्स। ओके, क्या होता है उसके पास, स्लिट्स होता है लाइक दिस। Okay, these are the slits which are having by the polarizer, इसको हम कहते हैं polarizer. Okay, देखो इधर, these waves which are acting actually vertically plane to the slits. Okay, and few of them what they are doing, actually they are varying like this, correct ना, दोनों wave, which wave will be propagate through this one? Let me know through the chat box. Among these two, wave 1, wave 2, which wave light will be propagate through this polarizer? Yes, good. Wave 1 will be propagate because wave 1, which is parallel to this slits which are present in a polarizer. That's why it is easily move here. Correct now? And further it will be move like this. Only one type of signals are coming. What about the second one? Second one क्या हो गया? Second one को क्या हो गया? Second one will be perpendicular to this slits. No, that's why it is completely obstructed, means completely absorbed from this slit, we can say. Right now, light. Now, here it is there, no, the waves. We can call this one as an polarized waves or polarized light, we can say this. Okay, okay. How we can say it's a polarized light or not? It is also needed on device. No, that's why we introduce one more device here. This is also looking like a polarizer only. Already I told you. Inside it, slits are there. Correct? These are the slits which are present inside it. We can call this one as a grating also. So many number of lines are present. Okay. It is called the analyzer. Analyzer बोलते हैं the light whether it is polarized or not from the polarizer. Okay, and it will give the final result. If it is polarized means final result will be, it will be provided here. Okay, and one more thing guys, one more point here. If you're going, this is the axis, actually they are lying in one axis. No, this is the axis, both are lying. This is axis. Okay, if you are going to rotate this analyzer from, this is a perpendicular axis. Okay, both are parallel means axis के 0 degree to up to 90 degree. Okay, क्या होता है 0 to 90 degree? If you are going to rotate clockwise or anti-clockwise, intensity decrease होता है. क्या लिख दिया मैंने? Intensity, yes. Intensity decreases continuously. Okay, further 90 to 180, again further intensity increase hota hai. 90 to 180, I will write I as an intensity. Intensity increases, and further 180 to 270, intensity again decreases, and again 270 to 360, intensity again increases. Okay, like this it will be takes place. Okay, this is the experimental evidence for the how to make the polarization of light from the unpolarized light. Correct? I hope you guys understood this one. Davangere students are saying, sir, increase your sound. Actually, I'm streaming guys here. I don't know why you people are saying like that. This is a complaint only coming from your end. Okay, Uttara Kannada, let me know. Your people also facing the same problem. I hope it is not. Correct? You people are not responding at all sometimes. I don't know. Okay, cool. Then this is the experimental evidence, polarizers and analyzers. Mein. Second experimental evidence kya hota hai? Yes. Second experimental evidence is that Nicol prism. Okay, Nicol prism kya hota hai? Dekho idhar. I will explain. Here I will take two prisms. Kitna prisms? Two prisms. Okay. Each prism का angle होता है 68 degree. कितना होना है 68 degree. देखो इधर. If you consider, okay, देखो prism किधर है भाई? आ गया. देखो 3 sides होना है ना. Okay. Just imagine it's a 2D prism. Okay. This angle is there, no? This angle will be 68 degree both the side. कितना होता है 68 डिग्री होता है. दो प्रिज्म को क्या करते हैं हम? जोड़ते हैं. मींस वी आर गोइंग टू अटैच दिस टू प्रिज्म विथ ए ग्लू. ये क्या है? ग्लू है बीच में। ओके, ग्लू को कहता है कनाडा बाल्सम, कनाडा balsam. Guys, do you know what is a Canada balsam? Actually, it is coming in chemistry, I think. Canada, it is like a cement, होता है, but it is a glue. It has a refractive index also. इसका refractive index होता है 1.65 something. Okay, completely transparent. Okay, this is the arrangement. This is the prism. देखो इधर prism इधर है. It will not looking good properly. That's why I write like that. ये है prism. Okay, right? In between these two prism, we are going to attach with a glue. We call that glue as an Canada balsam. Okay. Okay. This prism, how it will be work, I will explain first. Okay. This nickel prism also we are going to use it to find out the means or make the unpolarized light as an polarized light. Okay, just think करो, ये source है means source के पास क्या होता है, unpolarized light होता है. In all the direction it is emitting light. Okay, unpolarized light को कैसे denote करते हैं हम, like this. Correct ना? This is a unpolarized light. इसके बीच में क्या लिखना है, dots. Dot means they are active. Correct? Okay, cool. When they are incident over it, no? Here, after incident, देखो, सुनो, carefully सुनो. Hey, क्या हो रहा है इधर? हाँ, my computer is lagging, I don't know. Okay, this white light है ना, white like this they are acting. It will be diffraction होता है compulsory. It will be move like this without deviation. They are going to move like this. Okay, and red light से ना, red light उसके साथ आता है, but red light will take some deviation from this point onwards. They will take a deviation, and deviation. When it is incident at this point, किधर देखो लास्ट पॉइंट है, येलो कलर से डिनोट करते हैं. येलो हो गया ना, ग्रीन कलर लेता है मैंने. अरे यार क्या हो रहा है मेरे साथ आज. ओके, ग्रीन कलर है ना, अप टू दिस पॉइंट इट विल बी इंसिडेंट. आफ्टर दैट क्या होता है ना, ड्यू टू दिस एंगल ऑफ इंसिडेंस, इधर क्रिटिकल एंगल को इक्वल होता है. ओके, क्रिटिकल एंगल होता है. Okay, that is an arrangement made by this nickel prism. Okay, due to making the unpolarized light to polarized light. Okay, एक critical angle से बाहर होना है. When it is incident at the critical angle, no, it will be get reflected to the another medium like this. They will come like this in this medium. We call this one reflected ray, internally reflected ray, as an ordinary ray. Ordinary ray. Okay, and without deviation the rays are coming, no, we call this one as an polarized light. Polarized light rays, polarized light ray, or else we can call this one as an extraordinary rays. क्या कहते हैं इसको, extraordinary rays we will call. Okay, this is also a device which can make unpolarized light as an polarized light. कोई problem नहीं, right? This is a device. Okay, इधर critical angle कितना होता है, angle of incidence कितना होना चाहिए, it should be greater than the prism angle. Okay, that's why we can say here 69 degree is a critical angle. Okay, in this angle these waves which are deviates and incident on the glue, okay, then it will be reflected to the same medium. Cool, right? Nicholas prism or nickel prism is also device used to produce the polarized light from unpolarized light. Okay, cool. Next thing is that law of Malus. ये क्या है लॉ ऑफ मालस, करेक्ट ना? लॉ ऑफ मालस क्या है? Okay, law of Malus, it is very simple. It is very simple. Here unpolarized light is there. What is this? This is the polarized light, unpolarized light. When it is passing through the polarizer, क्या हो गया? एक polarized light बन गया. It will become polarized light. Okay, polarized light वो भी हो गया. Then after what we did actually, इस analyzer को ऐसे rotate कर दिया मैंने. रोटेट करने से क्या होता था? इंटेंसिटी ये इतना बड़ा था ना, ये छोटा हो गया लाइक दिस. एम्पलीट्यूड छोटा हो गया. एम्पलीट्यूड छोटा हो गया मीन्स क्या होता है? इंटेंसिटी आल्सो डिक्रीजेस. करेक्ट ना? इंटेंसिटी आल्सो डिक्रीजेस. कितना इंटेंसिटी डिक्रीज हो गया उसको पता करना है ना. इसलिए लॉ ऑफ मॉलस ने, मिस मॉलस एक साइंटिस्ट का नाम है, ही गिवन ऑन इक्वेशन. ओके, इंटेंसिटी के लिए एक इक्वेशन दे दिया. कैसे है? ऐसे देखो, I is proportional to the square of the cos angle. Square of the cos angle. ये एंगल किधर है? एंगल किधर का है उसको पता करना है. फर्स्ट देखो इधर, दिस इज द एनालाइजर. When they are both are parallel to each other through the axis, no, there is no angle between them like this. This is the analyzer, sorry, polarizer. This is the analyzer. When they are at the axis exactly, angle between them will be 0 degree. If I'm going to rotate this angle by clockwise direction, if I rotate the polarizer, sorry, analyzer by angle 90 clockwise direction, इसका angle क्या होता है? Continuously increase होता चाहता है. Correct ना? Continuously angle is increasing from the polarizer to analyzer. We need to discuss the angle between polarizer to analyzer. That is the angle we need to take. Angle means here angle between polarizer and analyzer. Okay, that angle we need to take along with the cos function. It is gives the value of intensity of light. He said. This is a direct formula, no worries. Okay, direct formula. Intensity of a light after the analyzer, how much it is there, you need to find out. Means it is depending upon the how much angle you want to rotate in a analyzer. Okay, almost all. When it is polarized, no, after polarization intensity will not change. After polarization intensity will be same here. Here intensity is same. There is no change in intensity, but due to the rotation of analyzer, intensity क्या होता है? Change होता है, right? Intensity will be changing due to the rotation of analyzer. Okay, that intensity measure करने के लिए क्या करना है? Just intensity is directly proportional to cos square of theta. Here theta means we are going to measure with respect to the polarizer. Okay, this is a law of Malus. Cool. Next thing is that polarization by scattering. This is a method. 1 mark or 2 marks question for this KCT they might be asked this one. Sorry. In board exam they might be asked this one. Polarization light by scattering of light. कैसे होता है स्कैटरिंग ऑफ लाइट? सन से लाइट आता है ना, वो अनपोलराइज्ड लाइट इन ऑल द डायरेक्शन इट इज स्प्रेडिंग. इफ इट इज इंसिडेंटिंग ऑन एनी मॉलिक्यूल्स मींस मॉलिक्यूल के ऊपर इंसिडेंट होने के साथ क्या होता है? एक्चुअली वी आर ऑब्जर्विंग द पोलराइज्ड लाइट, इट इज परपेंडिकुलर डायरेक्शन. करेक्ट ना? इन एनी डायरेक्शन इफ यू आर ऑब्जर्विंग यू कांट एबल टू सी इट, राइट? When it is incidenting on a molecules, if you are going to see the light through directly parallelly, okay, you will observe the same amount of unpolarized light. There is no change. If you're going to make some angle means further it is maybe a partially polarized, means some polarized means some waves will be decrease hota hai. You might be decrease hota hai. Polarization means amplitude is continuously decreasing, no, that's why. Further if you are coming to up to 90 degree, okay, this is a light direction. पहले light direction इधर था. Okay, if you are watching the unpolarized light in perpendicular axis में means at this point only the plane polarized lights are coming. Plane. Only this ways only we can able to visualize. At that condition you can feel like that intensity is thoda decrease or like that. Okay, this is the polarization thing which is happening in a by a scattering of light. Okay, simple है, कोई problem नहीं. Next thing is that polarization by reflection. Reflection में भी polarization होता है. कैसे होता है देखो, ये unpolarized light है. ये क्या है? Unpolarized light है. Okay, when this unpolarized light will be incident on the XY surface. Okay, surface का बीच नीचे में क्या है? Denser medium. Just think that it's a water medium. Okay, when it is incidenting, you know that there is no phase will be changes after refraction. Refraction में time में phase नहीं change होता है. इसको मैंने खुद बोला था when I am teaching the behavior of a wavefront through different media. Correct now? Now it is while refraction takes place. No, both the waves are coming. There is no change, right? But when it is reflected, इसका phase angle कितना change होता है? 180 degree change होता है. When it is changing, no, at the time only one type of wave will be reflected. Okay, we call this one as an plane waves. Okay, actually light is a plane wave. Always, if it is polarized means always it is possessing the plane polarization. Okay, but here condition is there. Condition क्या है? Incident angle के ऊपर depend होता है. Incident angle के ऊपर depend होता है. Incident angle कितना होना चाहिए? 45 degree से theta value. Okay, this IP value. IP means polarization angle. I will write this one. Yes, this polarization angle should be less than 90 degree and greater than 45 degree. In this condition only it will be takes place. Okay, that's why the scientist Brewster also given an equation to find out the value of angle of incidence, means polarization angle. He given like that one equation, mu is equal to tan IP. Mu is equal to tan times the IP. Tan means it is nothing but trigonometric function. IP means angle of polarization, incident of polarization angle. Okay, right? Okay, इसमें critical angle को पता करो means if they are asking about the critical angle means where you are going to take the critical angle, from where you will take, you know, right? Critical angle come it will become in total internal reflection. Correct now? What is that critical angle? Sin IC will be equal to 1 by mu. Sana, correct? Okay, from this angle, this is also very important to solve few examples here. Okay, keep in your mind. Here, Brevister's last says that the refractive index is equal to tan of the angle of polarization angle of the incident. Okay, just know this one. It is enough. Okay. Up to now, we discussed about the polarites and polarization of light. No, ये polarites क्या होता है? Actually, the devices which convert the unpolarized light to polarized light. These are called the polarites. Where we are using these polarites? Actually, you know, right? When we are traveling in the night time means you might be observed few people they are wearing the spectacles. Okay, why they are using the spectacles during in a time of night? Is that mad? No. क्या होता है? By using these spectacles, actually these spectacles are made by the polarites. Means actually they are in after here. Just imagine इसके ऊपर unpolarized light will be incident means Okay, it will allow only the one type of wave which are parallel to the polarites. Means क्या होता है? You might be getting my point, right? Means only one kind of wave which is coming means almost all intensity of light थोड़ा सा decrease होता है. Correct ना? Or as we can say like this, how just imagine you are traveling in a road in a night time. Opposite side में एक कार आता है. Okay, तो कार आने से क्या होता है? Car ka intensity light will be more than your vehicle. Just think like that. Okay, during that time in front of you some obstacles are there, means like a stones and anything. Okay, the light which is incidenting on a stone, it will not reflect to your eye. You want to see that stone? No, or else you're going to ride on the stone. That time you can't able to see, means almost all unpolarized light all are entering to your eyes. To control that unpolarized light, we are using the spectacles which are made by the polarites. Okay, by using this polarites, we can easily see that stone which are present inside this in front of our vehicle. In aeroplane also, we are going to use the same thing. Correct now, these are the few things which are important for the polarites as an application. Okay, this is all about, guys, wave optics. This is all about the wave optics. Tomorrow we will solve the numerical problems. Exactly, numerical problems only we are going to solve tomorrow class. Okay, and from the day tomorrow onwards, we are going to start the dual nature of light. Actually, we are running these classes just because of your examination purpose. Okay, first we are going to finish our chapters, and later on we will talking about the numerical problems. Okay, thank you guys. Thank you for attending the class. Okay, this is all about today's class. Okay, we'll meet in our next class, guys. Until then, take care. Bye bye.